So, electricity is the movement of electrons, but how does it actually work? Well, the flow of electricity can be harnessed in order to transfer energy from one place to another. When you turn on the lights, coal is being burned to create electricity, which comes through wires to your house. When you turn on the lights, electricity flows through the wire to the filament, which heats up, creating light. However, the electricity coming from the power plant is not the same kind that comes from a battery. There are two different types of power: direct current, or DC, and alternating current, or AC. When Thomas Edison invented the light bulb, he used DC current, or electrons moving in a constant flow from one place to another in a big loop. Shortly afterward, Nikola Tesla, a Serbian intern of Edison, came up with alternating current, where electricity moves kind of like a saw, back and forth, back and forth. Edison laughed at the idea, saying that it would never work. But Tesla found that it takes less power to move the electrons back and forth than it did to move them all the way around the loop. There are advantages and disadvantages to each. Direct current works best in digital circuits, like laptops, and is how batteries work. But if we used it today, we'd require a power plant every 5 miles. Alternating current is much more efficient over long distances. Have you ever seen big bricks in the middle of a power cord? That's because most modern devices, like computers and cell phones, have to convert AC power to the DC power that's required to run them, which is inefficient and produces a lot of heat. Regardless of what type of power you use, it is important to know how to measure it. First is voltage. Voltage is defined as electromotive force. If we think of it in terms of a water faucet, it would be how hard the water, or electrons, are coming out of the pipe. The unit that we use to measure voltage is the volt. Next is current, which is how many electrons are flowing through the wire at one time. You can think of it as how many gallons of water are coming out of the faucet. Current is measured in amperes, which is abbreviated to amps. Finally is resistance. Resistance is the circuit's ability to slow the flow of electricity and is measured in ohms. You can think of resistance like a block in the middle of a faucet. The relationship between these three terms can be described by Ohm's law, which states that voltage in volts is equal to the current times the resistance. By rearranging this equation, we can know one of the variables if we already know the other two. Go ahead and try it out on our website at yarca.org.